Welcome to Math Challenge 472. Math Challenge for all quantitative and numerical aptitude tests and competitive examinations. Here we have a system of circles. The radii of the circles are given indirectly, the area is given. In fact, the area of the circles are given by which we can calculate the radius of each circle, and we have to find the outermost red circle radius. The area of three inner circles are given, and we have to find the radius of the outermost red circle. Math Challenge 472. Now here we have a system of circles such that they are mutually tangent. The circles, the system of four circles, are mutually tangent. That means every circle touches every other circle at one point. Every circle touches every other circle at one point. So every circle is a tangent to every other circle. They are called mutually tangent circles, osculating circles, or sometimes loosely kissing circles. The circles drawn in such a way that all are mutually tangent. That means every circle will touch every other circle at one point. They are called mutually tangent circles or osculating circles. So here we have a system of four mutually tangent circles. The relation among four such mutually tangent circles is given by Descartes' theorem or Saudy's rule. They relate the curvatures of mutually tangent circles. Now, what is curvature? Don't be confused. Don't be nervous. Curvature, it is a very simple concept. Curvature might be a new term for you, but it's a simple and easy concept, as we shall see. So they are relating the curvatures of four mutually tangent circles according to Descartes' theorem or Saudy's rule. But first we will see what is curvature. Now curvature K of a circle is the inverse of its radius. Curvature is 1 by radius or K equal to 1 by R. The reciprocal of the radius or inverse of the radius is called curvature. Curvature equal to 1 by radius. The inverse of radius or reciprocal of radius, that's curvature. If radius is 2 meter, curvature would be 1 by 2, 0.5 meter inverse. If radius is 10 centimeter, curvature would be 1 by 10, that is 0.1 centimeter inverse. The unit of curvature would be inverse of the unit of length. Radius to meter, so curvature we are getting in meter inverse. If radius is in centimeter, 10 centimeter, then curvature is in centimeter inverse. So radius 2, curvature 1 by 2, radius 10, curvature 1 by 10. Curvature is 1 by radius, inverse of radius or reciprocal of radius. Now first we find the radius of the three circles. Area A is given by pi r square. So r equal to square root of area by pi. So first circle 100 pi. So the radius would be 10. The curvature would be 1 by 10. Second circle, the radius is 3. So the curvature would be 1 by 3. And third circle, it is radius 2. So curvature 1 by 2. Right? 1 by radius, that is curvature, and radius would be square root of area divided by pi. So 100 pi divided by pi 100, square root 10, radius 10, curvature 1 by 10. Similarly, 4 pi divided by 5, 4, square root 2. So radius 2, curvature 1 by 2, and so on. So we get the curvatures as 1 by 10, 1 by 3, and 1 by 2. And this last, the outermost red circle, suppose the curvature is k. If the curvature is k, when we find out k, then we can find out the radius as inverse of curvature. So let the curvature be k. And the given circles Curvatures are 1 by 10, 1 by 3 and 1 by 2, and the unknown curvature K. So the curvatures we got is 1 by 10, 1 by 3, 1 by 2. Now let the curvature of the outermost red circle be K. Now according to the rule, K1 plus K2 plus K3 plus K4 whole square. That means first you add the curvatures and then square. A square of the sum of curvatures to the ratio K1 square plus K2 square plus K3 square plus K4 square. That is, first you square then add. Sum of squares will be 2:1. Square of the sum is to sum of the squares 2:1. So put the values 1 by 10, 1 by 3, 1 by 2 and K, and here squares 1 by 10 square, that is 1 by 100, 1 by 3 square, that is 1 by 9, 1 by 2 square, that is 1 by 4 plus K square. This ratio should be 2:1. The first we add and then square, and in the second we square and then add. So square of the sum and sum of the squares. The ratio should be 2:1. So this ratio should be 2:1. So we got 1 by 10 plus 1 by 3 plus 1 by 2 plus K whole square is to 1 by 100 plus 1 by 9 plus 1 by 4 plus K square is 2:1. Now add and simplify and then cross multiply and simplify. Ultimately you will get the quadratic equation 225K square minus 420K minus 29 equal to 0. What we are doing, we are adding and simplifying. Take the LCM, add as usual. This 14 by 15 plus K whole square. Expand it using A plus B whole square formula. Then cross multiply. Product of extremes equal to product of means. And finally you will get the quadratic equation 225K square minus 420K minus 29 equal to 0. Now we will solve this quadratic equation to get the values of K, two values, but one of which we will reject. Now this quadratic equation, when you factorize, you can see how we have factorized. We are getting K equal to 29 by 15 or minus 1 by 15. Now don't be tempted to reject the negative one for two reasons. One is 29 by 15, right? So the radius would be 15 by 29, which is 15 by 30 is half. So approximately half. But this circle is much bigger. Here we got the radius 10, radius 3, radius 2, and the circle is much bigger than that. So the radius cannot be half. That is, it can't be less than 1. So we reject. And minus 15 is accepted because according to sign convention, the outer circle, the circumscribing circle, is supposed to have negative radius, a negative curvature. The circumscribing circle, the outer circle which circumscribes the other three circles, the curvature should be negative. That's why we are getting a negative value. So radius would be, according to the sign convention, minus 15, but actually 50. So required radius is 15 because according to the sign convention, the curvature is negative. So radius is also negative. But since we will take only the positive, the numerical value, so required radius is 15. Do not take this value 15 by 29, which is approximately half, less than 1, because the circles are radius 10, radius 3, radius 2, and the circle, outermost circle, is much bigger than 10. So if we take this minus 1 by 15 curvature of minus 15 radius, but minus is allowed because according to sign convention in the Descartes theorem and Soddy's rule, the circumscribing circle has a negative curvature. So because it is an outer circumscribing circle, it will have a negative curvature. So that is why we have got minus curvature and minus radius, but we will take only the absolute numerical value. So radius is 15. So the required radius of the outermost red circle is 15 units.
Was that interesting? If you have any other method, we would love to learn from you. We shall come back with more interesting videos. Like, share the videos, and subscribe to our channel if you are a math lover. Till then, goodbye.